Hi, everybody. My name is Bernie Wu. I'm, again, the VP of Business Development and Alliances for MemVerge, and I'm pleased to be here to give you an idea of our vision for a software platform for providing CXL memory services. Since this is our first time at OCP, I thought I'd start by giving you a little bit of background on MemVerge's history and why I think we're in a unique position to really assist this industry in bringing CXL to the users. The company was founded 5 years ago by our CEO, Charles Fahn, who used to be the Senior Vice President, General Manager of VMware's vSAN area, and then another gentleman, Shuki Brook, who was one of the founders of Extreme IO, a distributed flash storage technology company that was sold to EMC. Those two, together with Yue Li, who presented yesterday, he's our CTO. Yue presented at the Future Technology track on our memory snapshot area. Those three gentlemen got together and created the world's first software-defined memory product. And that was driven by the advent of storage class memory. The Intel at that time had released persistent memory, and so between DRAM and persistent memory, there was a significant difference in performance. And the Memory Machine's mission at that time was to virtualize that and create a transparent user experience that included expanded memory and then and automatic memory tiering, as well as advanced memory services like the snapshot technologies we talked about yesterday. Along the way, since then, we've gotten quite a lot of participation from the industry in terms of investment, and we've raised $93 million thus far. And we've also picked up customers along the way. So we have customers, some are in the hyperscaler area, some are in financial services, and many are also in the HPC and what we call big memory area. So basically, the message I would leave you is that MemVerge has already gone through 5 years of bumps and bruises in trying to perfect automatic memory tiering and also some of these advanced memory services like snapshots. CMAC already covered this morning this CXL 3.0 roadmap, and the way I would soundbite this is that in roughly 12 to 18 month intervals, we will see different phases of CXL being rolled out. The first implementation will be memory expansion, and then the next CXL 2.0, the main theme I look at, it will be memory pooling, and then CXL 3.0, memory sharing, or real enabling collaboration at a new kind of level. And we intend, during the course of this rollout of CXL over the next several years, to pace these hardware innovations with software innovations. As a matter of fact, we consider the development of that software to be really the core of making sure that this CXL initiative is successful. And we see the software being developed on both sides of the wire, both on the host side, which I'm showing there on the left side of this chart, and then also on the right side. And this diagram is showing a kind of a vision of where we see software being needed and developed over the next several years. So on the right side, what we're seeing is what we call the Global Fabric Area Memory Orchestrator and Fabric Manager. So there already are specifications, of course, for Fabric Manager API, but there's a lot of software that needs to be developed there. So let me dive into that a little bit here right now. So first thing, obviously, is things like memory provisioning and sharing, basic management of that pool. We also see need for data protection of this pool. It's obviously going to have a large amount of volatile and maybe non-volatile memory, but it needs to be protected. So it could be a very large blast radius, security, implementation of confidential computing, global insights, fleet collection of telemetry, metrics, fleet management of different types of memory, and then capacity optimization. We see an increasingly diversified types of memory being implemented, capacity optimized, performance optimized. We see storage class memory, memory semantic SSDs, all of that needing optimization and management. And those two sides, the host side and the fabric side, need to be closely coordinated. The host side we see as being a thicker footprint than perhaps maybe what we saw evolve in the storage area networking industry, because the fact that we have this coherent memory architecture across this fabric that has to be maintained. We also see different applications needing different qualities of service of memory. Some, as other people have mentioned, can be maybe 100% in the pooled memory at some lower tier of performance. Other kinds of applications may need to be completely local memory for performance reasons. So that's just an example of why we see a close coordination between the host side and the back-end global fabric area manager orchestration. And what I'll do now is I'll deep dive into what MemVerge has built so far. So this next slide shows our memory machine. We call it a machine, but it's like just a piece of software running on top of the Linux operating system. So the way it's installed currently is through an LD preload. And so above us are applications. And the applications could be, bare metal applications for genomics, EDA, simulation, whatever. The applications also can be more like platforms. So we do support Kubernetes. We've developed integration, for example, with we have a Kubernetes operator, so we can present memory tiering into Kubernetes pods. We also support things like KVM. But anyway, the idea is that this memory machine can be installed easily on a user space approach. And what we do is then take the memory below us, and if there's different types of it, we'll create memory pools and then implement intelligent auto-tiering of that memory. So what we do is we profile the applications or the process trees so that can be adjusted. And we then apply our policy engines to it, and we decide which pages to promote or demote, hot, cold pages, similar to what we just heard in this previous talk, and then handle that tiering in an automatic, dynamic fashion. And the main point is that no changes need to be made to the application. There are a lot of applications that are highly tierable. In addition to that, we've added this memory snapshot service, which our CTO talked about yesterday. And just a quick recap of that, what we have done is implemented what we call copy on write memory snapshotting capability. And that allows us to transparently snapshot applications and processes while they're running in memory. And that allows all sorts of interesting use cases in terms of being able to roll back the state of a machine, to be able to restore it or actually clone it, or even move the whole application more quickly to another machine. An example of moving that application is in the cloud today with a public cloud where there's not even memory tiering available. We use this snapshot technology in conjunction with integration with some of the public cloud APIs to allow long-running applications that were never designed to be fault tolerant to run on spot instances. So when a spot instance gets recalled by Amazon or Azure, you may only get 2 minutes or even 30 seconds warning that this spot instance is getting preempted. We take a memory snapshot, and then we can transport the application and restart it on another spot instance, things like that. So along the way, we've also had to learn a lot about how to integrate this memory tiering and this memory snapshotting technology in with schedulers of various types, Slurm, UGE, LSF, et cetera, and then also how to integrate it into cloud architectures, AWS, batch, et cetera. So early results. Because we did all this work originally up until early this year, focused on tiering between DRAM and persistent memory. And persistent memory is maybe 3 times slower in terms of latency. So since we did all that work, when CXL first started sampling the technology, we were able to very quickly pivot, basically almost no changes to our code, to doing tiering using CXL near and far DRAM. And so the results look promising, similar to what we just heard from Meta, that we can actually get a higher, not only higher capacity, but higher bandwidth by tiering, as opposed to using each tier separately. So that's what these benchmarks show, that the black line on each triplet shows our MemVerge memory machine, and the total amount of bandwidth is, as you can see, exceeds that of the individual tiering on DDR local or DDR remote. Oh, that's another benchmark right there. I forgot to show. And then the other thing that we've been working on is leveraging hardware-assisted memory profiling using technologies like from AMD to IBS. And that also has improved the precision and the dynamic responsiveness of our memory tiering. And so this just highlights the benefits of using something like that technology to improve overall throughput by tiering more dynamically with more accurate profiles of accesses, memory accesses, using hardware-assisted capabilities here, in this case from AMD. Like Meta, we've also developed tools to assist in taking a look at applications and profiling behavior once CXL is implemented. So we have a memory viewer tool that is actually available free from our company to interested parties that allows you to see both tiers in action. So the upper right graph there shows the local DRAM bandwidth, and then the lower one shows the CXL-based bandwidth. In addition to that, this memory viewer also does provide a heat map. So again, we can determine which applications are the best candidates for implementing on a tiered architecture. This next slide shows you where I see some of the memory services that we can offer through our software platform. We've already talked a lot in this conference today about the stranded memory problem. So we see us being able to facilitate automatic tiering and again, the dynamic profiling of either applications or virtual machines. And then also, we've also heard this morning about the problem of underutilized memory or stranded memory. But in addition to that, within the virtual machines, a very large amount of over-allocated memory. So we can do optimization there. The composable memory infrastructure area is also a very intriguing use case for lowering TCO. We're already partnered with companies like Liquid to provide composable memory solutions today. But I see that really greatly expanding once CXL 3.0 comes around. And then also increasing the resilience of these solutions. So we see opportunities to, for example, if a local DIMM fails on a server, we can bring in a new DIMM from the pool and then transparently migrate the data from the failing one to the new one in the pool, so that we can have a much higher level of resilience for applications. And then again, using our transparent checkpoint and recovery technologies, we can provide data protection with using high-speed memory snapshots to reduce the recovery time, recovery point objectives. In addition to that, I think one of the most exciting things I see is the ability to collaborate through shared memory objects or shared or snapshots in our case. So we're already starting to see that even before CXL. We have customers that have discovered that they can collaborate using our memory snapshots to study, do root cause analysis and things like that in a more parallelized fashion. And then another interesting use case, I think, again, that will improve what I call time to insight, will be to help consolidate some of these just what are currently distributed memory cache architectures. A lot of IM in-memory databases have their own memory caches and on individual nodes. Now we can imagine a scenario where we can put all those caches into a centralized pool and get better performance and through that approach. Similar situation, I think, exists with architectures like Spark, which are used for analytics, where, again, we can consolidate the memory and speed up operations like TerraSort and things like that, reduce the amount of shuffling going on in the different stages of the Spark workflow. So in short, I want to let you guys know we see this CXL as a transformation together with the hardware and the software to enable what we call a memory-centric data center. And again, we see 3 phases to this rollout of this technology. So right now, I would say we're in the first or second inning of a very exciting several years ahead of us. And that first starting point will be memory expansion with tiering that provides both capacity and bandwidth expansion. And then shortly after that, memory pooling and composable infrastructures. And then ultimately, I think memory sharing will be and use cases around that will be the what I would consider the killer apps for CXL, because I think it's not only a TCO story, but it's also a story about time to insight. And so we're really excited about this because for the first time in history, we're able to work together with the rest of the industry in what we call software-defined memory. And as you can see from my presentation, there's a great deal of need for software in this sector to unlock the total value of CXL. And with that, I'd like to summarize by saying that we see CXL as being a major game changer in this industry to enable big memory. Secondly, we see software both on the host side and inside the fabric itself to be a key to unlocking these solutions. And we're very excited to partner with the rest of the industry through OCP and the composable memory working group now, the SNEO organization, and the CXL consortium. We're very excited to now participate in delivering these solutions to the rest of the industry and users. And the last thing I'd say is that MemVerge already has a good head start on supporting CXL from our experience working with memory tiering and snapshotting. And so we intend to deliver the best-in-class CXL middleware software to solutions and help bring those applications to this industry as quickly as we can. So with that, I'd like to thank you for your time and hope you enjoy your lunch. I'll be out there in the courtyard to answer any questions.
All right, the box lunch cart should be there at 11:30. The tables are set up. Please join us. We're going to reconvene at 12:30. Going to hear from VMware.